Well, today's supposed to be a review on functions, but I don't know where everybody's at.
Parkour! Parkour!
Parkour!
Parkour!
Parkour!
The team saw a video on YouTube of parkour, and everyone thought it would be funny to jump around and do it in the office. It kind of gets in the middle of work and distracts some people. So I'm guessing you guys got the email from Jan about the functions review. This is really hard and difficult to do.
That's what she said.
Alright guys, thank you for calming down. Now we can finally get to this review that Jan's making us do, and we need to get it done ASAP. So this is a function. It's denoted by this, y equals f of x, the special type of equation involving two variables. Often one variable is somehow linked to another, more often than not. In relationship from one set of inputs to a set of possible outputs, each input is related to exactly one output. And this function was found in the 17th century. Guys, I can't do this. You just keep joking around. Dwight. Involves two variables, and more often than not, they're linked to each other, and there's a pattern.
Okay, go ahead.
Okay, so in order to figure out if this is a function or not, you gotta use the vertical line test and check how many times it touches. If it touches more than once, it's not a function. So it only touches once here, 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 and supposedly over here. So since it doesn't touch anywhere more than once, it is a function, so it's a yes. Woo.
Give it up to Stan.
Vertical line test.
You know, for being able to manage a branch for nearly 20 years and always have these corporate meetings because we're always updating our procedures and policies, sometimes you just gotta spice it up. But as much as fun as I am, I just cannot get through some of these meetings, especially when Stanley talks or Dwight, or really anyone besides me, because let's be honest, I'm kind of the greatest presenter there is out of this whole team.
So to make sure if it's a one-to-one function, we gotta use the horizontal line test. So we draw it horizontally, and if it touches more than once, similar to the vertical line test, then it's not a one-to-one function. Since this only touches once over here, once each time, it is a one-to-one function. Woo.
Okay, give it up to Stanley. Nardog, you're next.
Alright guys, so I'm going to talk to you about the magical powers of transformations with functions. So here we have a parent function, x squared. As you can see, it's a parabola. So right now, I'm going to show you how to horizontally transform that function. So, up here in the corner we have an example of shifting the function right. So to shift, or when you transform a function horizontally, you can either shift it left or right across the coordinate plane. To shift right, you can subtract a number inside the function like so. Wow. And if you want to shift it to the left, you go ahead and add inside of the function. So as you can see, x minus 3, x plus 3 inside the function. Leave the 2 outside, And there you go. Now, when it comes to vertical functions, well, again, we have the parent function right here. You can shift up or down on the coordinate plane. And in order to do that, you just add any number outside of the function. So right here, we got shift up the coordinate plane by 3 units, which, as you can see, once again, here's the parent function. You just add outside of it. And if you want to shift down, boom, bing, it is on the bottom. All you gotta do is subtract outside of the function. There you go. That is vertical transformations. All right. Now, reflecting is another thing you can do with transformations. So you can either reflect through the x-axis, which is this right here, or through the y. So the first one that we have is a reflection through the or across the x-axis. So here's the parent function, and here is the reflection. So in order to reflect across the x-axis, you just add a negative outside of the function. So as you can see right here, here's the parent function. Just add a negative outside, boom, bada bing, there is your reflection. Now, to reflect across the y-axis, this one's a little funny because as you can see, this is the y-axis right here. And when you reflect across the blue line, that's the reflection, it covers the parent function. So that's just a funny thing about parabolas. But to reflect across the y-axis, you go ahead and just add a negative inside of the function. So here we have the parent, x squared, and here is your reflection across the y. Alrighty, and the last but not least, stretching and compressing, right? We got here the parent function x squared, the red, and this right here is stretching it. So to stretch a function, you simply add a fraction in front of the function like so. So we got here 1/4 x squared. You get this magical looking line that's super duper big, kind of like Stanley. I'm just kidding. He's a cool guy. Okay, and here is compressing or condensing a function. You you go ahead and add a whole number in front of your function, like a 4, 3, 2, doesn't matter. So parent function here again, x squared, and this is your condensing. So purple is condensing, making it skinny, and the red is your parent function. So with all those cool, awesome transformations, you can have fun and make a lot of cool things.
You know what? I think something's happening to your Prius. I think you should go check it out.
Oh shoot.
Yeah, you should go. Yeah. So Jan told me to read this fax to you guys, this memo. I don't know, it's some safety procedure, it's stupid. But we're just gonna wing it. So as far as functions go, there's 6 types of functions, as you can see. Are you paying attention, Dwight? I don't think you are. Yeah, I'm watching. So, you know, as you can see, this is a square root function, and the domain is going to be left to right, so it's going to be from 0 to infinity, and then if you're going from up to down, which would be the range, it's going to be from 0 to infinity as well. And the line actually touches at 0, 0, which is why it would be the only intercept. It's not even or odd, and it increases at 0 to infinity. So this would be the square root function. As you can see, square root f of x equals square root function of x. So take a look at that. Moving on. Okay, next one, cube root function. This is, as you can see, this is f of x equaling the cube root of x, and as you can see, the domain, left to right again, it's going to be negative infinity to infinity, and the same for range. And so for the intercepts, it's actually going to go through 0, 0, as you can see right here, and it's odd, and it increases actually from negative infinity to infinity. Use your eyes, people. No max or min. Moving on. Oh, look at this. Absolute value, f of x. This is the absolute value, like I said before. It's going to go like a V. And the domain is going to be negative infinity, left to right, to positive infinity. As for the range, however, it's going to go from up to down, so it would be 0 to infinity. And as for the intercepts, again, it crosses through at 0, 0. It's even, and the absolute minimum is f of 0 equals 0. And it increases at 0 to infinity and decreases from negative infinity to 0 as it goes through right here again. Let's move on. Oh, look at this square function. This will be the f of x equals x squared. So as you can see, it's a little bit of fun. So if you want to put your hands up kind of thing, the domain would be negative infinity to infinity. The range is going to be, again, up to down, so it's going to be from 0 to infinity. The intercept crosses through at 0, 0, and it has an absolute min of f of 0 equals 0. Moving on again. So this one is going to be the cube function, so this is going to be x cubed. The domain, again, left to right, negative infinity to infinity, range, negative infinity to infinity. The intercept would be right here again, so it's going to be a 0, 0, and then it's going to be an odd function, and it increases at negative infinity to infinity. Last one, thank God. Okay, so the last one is going to be the reciprocal function. This one is kind of different from the rest because this one doesn't even touch the x or the y-axis. So the domain would actually even have a union. So it would be from negative infinity to 0, and then it's going to go from 0 to infinity. As for the range, it would be negative infinity to 0, and then 0 to infinity. So this way for range, this way for domain. No intercepts because it never touches the x or y-axis. It's odd, and there's no max or min, and it decreases at negative infinity to 0 and 0 to infinity. Thank God, we're almost done with this meeting. Dwight? Lead us off, Dwight.
So Brett and Stacy and Jesse, these are the elements that correspond in this side, high school seniors. And as you can see, there's at least one element corresponding to each side from the GPA side. So to understand what range is a function in correspondence between two sets, where each element in the first set is related. And in this example, the range is the GPA, which includes 3.2, 4.0, and 1.2. And for and as you can tell for GPA, each of these correspond exactly one element from the second set.
Guys, in conclusion, that covers everything we had to do for the review that Jan said. And thank you guys, and now let's go.
That's all, folks.
Wait.
It's okay.
I don't have to say it. See the giggles.
I don't know what to do.
You know, like those artists that like do random.
Well, today's supposed to be a review on functions, but I don't know where everybody's at.
Parkour.
Well, today's supposed to be a review on functions, but I don't know where everybody's at.
Parkour.